Because we are 70% water and only 30% land, the challenge of creating something new that isn't just a copy of existing models becomes even more important. The idea is to create a product that stands out but still remains practical and revolutionary in its own way. Elon Musk, known for his boundary-pushing innovations, reveals his latest creation, which could potentially revolutionize the world as we know it. Having looked into it, it's clear that this innovation is legitimate and could indeed change everything. However, the process of making hydrogen, storing it, and using it in a vehicle is no easy task, and this is where Musk's latest project, introducing the water engine, comes in. This bold new technology promises to disrupt industries and reshape the global energy landscape, offering a solution that could potentially end all competition in the energy sector. For years, people have been asking about what the next big product will be. Now, Musk and his team are not just talking about new products but actively designing two groundbreaking new products that could change the game. The water engine, which runs entirely on water, presents a sustainable energy solution that could revolutionize the future of transportation. Unlike anything seen before, Musk believes that water, a resource so abundant and renewable, could serve as the primary fuel source for vehicles, and that this idea is not only physically possible, but that they can make it happen. Replacing diesel trucks with hydrogen-powered vehicles could make a huge difference in advancing the mission of sustainable energy and transportation. This effort is one of the cornerstones of Musk's broader goal, to help drive humanity toward a more sustainable and energy-efficient future. The concept of using water as a primary fuel source for vehicles has been discussed by scientists for decades, though often dismissed as too futuristic or even impractical. Yet, if anyone can make this concept a reality, it is Elon Musk, with his expertise, resources, and a team of world-class engineers. A water-powered engine could change our approach to energy, fuel, and transportation, offering a cleaner, more sustainable alternative to current methods. But how exactly does this water engine work, and what does it mean for the future of both transportation and the environment? More importantly, how is Tesla planning to turn this ambitious idea into a working, marketable reality? Chapter 1. The vision behind the water engine. Elon Musk has long been vocal about his vision for a sustainable future. For years, his efforts through Tesla have focused on electric vehicles, seen as an important step in reducing greenhouse gas emissions. However, Musk understands that the fight for sustainability requires more than just electric cars. It demands bold new ideas and innovations. The water engine is rooted in Musk's commitment to clean energy, pushing the boundaries of what's possible. Unlike traditional internal combustion engines that rely on fossil fuels, leading to harmful emissions, a water engine would use water as its primary fuel source, creating a much cleaner and more sustainable alternative. This technology aligns perfectly with Musk's broader mission to accelerate the transition to sustainable energy. Musk's motivation to develop a water engine goes beyond just reducing carbon emissions. He's aware of the geopolitical and economic consequences of fossil fuel dependence. The volatility of oil prices, coupled with the environmental damage caused by extracting fossil fuels, has made it clear that the world needs a more sustainable, equitable energy source. Water, abundant and renewable, offers a solution that could address these challenges. Musk envisions a future where vehicles aren't just electric, but powered by water, making clean energy available to everyone, not just those who can afford it. By making this technology accessible and affordable, Musk believes Tesla can lead the charge toward a greener and more sustainable future for the world. Chapter 2. The science behind the water engine. To understand how Tesla's water engine works, we must look at the science that makes it possible. The idea of a water engine is not entirely new. Engineers and scientists have explored the concept for years, but a practical and efficient implementation has remained elusive until now. The key to the water engine lies in hydrogen. Water, H2O, is composed of 2 hydrogen atoms and 1 oxygen atom. By splitting water into these constituent parts, you can obtain hydrogen gas, which can then be used as a fuel source. This process is known as electrolysis, which involves using an electric current to separate the water molecules into hydrogen and oxygen. However, Traditional methods of electrolysis have been energy-intensive, requiring more energy to produce hydrogen than the hydrogen actually provides. This inefficiency has been one of the major barriers to widespread adoption of hydrogen as a fuel source. But Tesla's water engine uses a new, more efficient method of electrolysis, leveraging advanced materials and cutting-edge technology to reduce the energy required to produce hydrogen. This breakthrough makes the water engine not only viable, but also highly efficient. Once hydrogen is produced, it can be fed into a fuel cell, where it reacts with oxygen from the air to produce electricity. The only byproduct of this reaction is water vapor. This electricity is then used to power an electric motor, much like a traditional electric vehicle. However, unlike traditional electric vehicles that rely on batteries, hydrogen-powered vehicles can be refueled in minutes and offer a much longer range. Tesla's water engine also incorporates a novel method of capturing and recycling the water vapor emitted by the fuel cell, turning it back into liquid water and using it again for electrolysis. This closed-loop system significantly reduces water consumption and increases overall efficiency, making it one of the most sustainable power systems ever developed. Chapter 3. Overcoming the challenges. Developing a water engine comes with its own set of challenges. One of the most significant hurdles is the efficiency of hydrogen production. Traditional methods of electrolysis have been costly and energy-intensive, making hydrogen an impractical fuel for most applications. Tesla's new technology promises to address these issues, offering a more efficient and affordable process for hydrogen production, potentially making it a viable fuel source for mass-market applications. Another challenge is hydrogen storage. Hydrogen, when stored as a gas, is highly flammable and requires special handling. Tesla has overcome this issue by developing a new type of hydrogen storage tank that is lightweight yet highly secure. Made from advanced composite materials, these tanks are designed to withstand extreme temperatures and pressures, ensuring that hydrogen can be stored safely and efficiently. In addition to the technical hurdles, the infrastructure for hydrogen fueling is still limited. There are only a handful of refueling stations available in certain regions. Tesla plans to build a network of hydrogen refueling stations similar to its supercharger network for electric vehicles. These stations will be strategically placed along major highways and in urban centers, ensuring that Tesla's water-powered vehicles have easy access to refueling. Public perception of hydrogen as a fuel source is another major challenge. Hydrogen has faced skepticism due to safety concerns and the perception that it is less practical than other fuels. Tesla will need to conduct an extensive marketing and education campaign to convince consumers that hydrogen is not only safe, but also a superior alternative to gasoline and even electric batteries. If anyone can change the narrative, however, it is Tesla, with its reputation for innovation and disruptive technology. Chapter 4. Engineering marvels behind the water engine. One of the most exciting aspects of Tesla's new water engine is the engineering that has gone into making it a reality. Musk has always pushed the boundaries of engineering, and the water engine is no exception. The heart of the water engine is a new proprietary fuel cell that is smaller, lighter, and more efficient than anything currently on the market. This fuel cell uses a novel catalyst that significantly speeds up the reaction between hydrogen and oxygen, producing more electricity with less waste. The result is a fuel cell that is not only more efficient but also more durable, capable of lasting for hundreds of thousands of miles without degradation. Tesla has also developed a new type of electrolysis cell that uses advanced materials to reduce energy consumption. Traditional electrolysis cells rely on expensive metals like platinum as catalysts, but Tesla's new cell uses a proprietary alloy that is both cheaper and more effective. This innovation could drastically reduce the cost of hydrogen production, making it competitive with gasoline and diesel. The vehicle itself is an engineering marvel. Tesla's water-powered car features a lightweight chassis made from high-strength aluminum and carbon fiber, reducing the weight of the vehicle and improving fuel efficiency. The car's aerodynamic design minimizes drag, further enhancing its range and performance. Inside, the vehicle is equipped with cutting-edge technology, from a state-of-the-art infotainment system to advanced driver assistance features, ensuring that Tesla's water-powered cars are not only sustainable but also practical and affordable. Chapter 5. The Impact on the Automotive Industry. Musk's announcement of a water engine is already sending shockwaves through the automotive industry. For years, electric vehicles have been seen as the future of transportation, with Tesla leading the charge. However, the introduction of a water-powered vehicle could change the game entirely. Traditional automakers have been slow to embrace electric vehicles, often citing concerns about range, charging infrastructure, and battery costs. A water engine could address these concerns by offering a clean, efficient alternative to gasoline and diesel without the drawbacks of traditional electric vehicles. The introduction of a water engine could force other automakers to rethink their strategies. Companies that have invested heavily in electric vehicles may need to pivot toward hydrogen, while those that have been slow to adopt new technologies may find themselves left behind. This could lead to a major shakeup in the automotive industry, with new players emerging and old ones struggling to keep up. Beyond the automotive sector, the widespread adoption of hydrogen as a fuel source could reduce global demand for oil, potentially destabilizing energy markets. Additionally, hydrogen-powered vehicles could help reduce greenhouse gas emissions, contributing to the fight against climate change. Chapter 6. Environmental Benefits and Sustainability. The environmental benefits of the water engine are perhaps the most compelling reason for its development. Unlike traditional internal combustion engines, which emit harmful pollutants, the water engine produces only water vapor as its emission. This makes it an incredibly clean alternative to gasoline and diesel vehicles. If the water engine can be scaled for widespread use, it could significantly reduce global carbon emissions, helping mitigate the effects of climate change. Furthermore, the widespread adoption of hydrogen as a fuel source could reduce humanity's reliance on fossil fuels. Hydrogen is the most abundant element in the universe and can be produced sustainably from water. This offers a promising alternative to oil and gas, reducing not only emissions, but also the geopolitical and economic instability caused by fossil fuel dependence. As more companies and governments invest in hydrogen infrastructure, the transition to a hydrogen-powered world becomes more feasible. The byproduct of Tesla's water engine makes it one of the cleanest forms of transportation available by using water as a fuel source. Tesla's water engine could significantly reduce greenhouse gas emissions, which is particularly important in the fight against climate change, as transportation is one of the largest sources of carbon emissions. By providing a clean, sustainable alternative to gasoline and diesel, the water engine could help to reduce our carbon footprint and protect the planet for future generations. Additionally, the water engine could reduce our dependence on fossil fuels, as oil drilling and extraction have significant environmental impacts, from habitat destruction to water contamination. By reducing demand for oil, the water engine could help preserve natural ecosystems and protect biodiversity. The water engine also has the potential to improve air quality. In many cities around the world, air pollution is a major public health concern, contributing to respiratory diseases, heart conditions, and other health problems. By eliminating tailpipe emissions, the water engine could help improve air quality and create healthier, more livable cities. The introduction of a water engine could have far-reaching economic implications. For consumers, a water-powered vehicle could offer significant cost savings. Water is abundant and cheap, and with Tesla's new electrolysis technology, the cost of producing hydrogen could be competitive with gasoline and diesel. This could lead to lower fuel costs and reduced operating expenses for vehicle owners. For automakers, the water engine represents both an opportunity and a challenge. Those that can adapt to the new technology could gain a competitive advantage, while those that are slow to change may find themselves struggling to keep up. This could lead to increased competition and innovation in the automotive industry, ultimately benefiting consumers. The water engine could also create new opportunities for growth in other sectors. For example, the development and deployment of hydrogen fueling infrastructure could create jobs and stimulate economic activity. Similarly, the production of hydrogen could create new markets for renewable energy, as electrolysis can be powered by wind, solar, or other clean sources. The success of Tesla's water engine is closely tied to the development of renewable energy. Electrolysis, The process used to produce hydrogen requires electricity, and the environmental benefits of a water engine depend on the use of clean, renewable energy sources. Elon Musk has long been a proponent of renewable energy, and Tesla is well positioned to lead the way in this area. The company's gigafactories are already powered by solar energy, and Tesla's solar panels and battery storage systems could play a key role in creating a sustainable hydrogen production system. By integrating renewable energy into its hydrogen production process, Tesla can ensure that its water engine is truly sustainable, reducing emissions and promoting clean energy. This approach also aligns with Musk's broader vision of creating a sustainable future for humanity, one that is not dependent on fossil fuels. Despite the promise of a water engine, there are still significant barriers to its widespread adoption. One of the biggest challenges is infrastructure. While Tesla has announced plans to build a network of hydrogen refueling stations, this will require significant investment and time. In the meantime, consumers may be hesitant to adopt a new technology without a reliable and accessible refueling network. There are also concerns about the safety of hydrogen as a fuel source. Although Tesla has developed advanced storage tanks to minimize risks, hydrogen is still highly flammable and requires careful handling. Public perception of hydrogen safety will need to be addressed, and consumers will need to be educated about the benefits and risks of the technology. Finally, there is the challenge of cost. While Tesla's new electrolysis technology promises to make hydrogen production more affordable, there are still questions about whether it can compete with gasoline and diesel on price. Consumers are unlikely to adopt a new technology if it is significantly more expensive than existing options. The announcement of Tesla's water engine marks the beginning of a new era in transportation. While there are still many questions and challenges to be addressed, the potential benefits of a water-powered vehicle are enormous. Elon Musk has always been a visionary, and the water engine is just the latest example of his ambition to push the boundaries of what is possible. If successful, the water engine could revolutionize not only the automotive industry but also the entire global economy, changing the way we think about energy, transportation, and sustainability. As we look to the future, one thing is clear: Tesla's water engine represents a bold new vision for a cleaner, greener, and more sustainable world. Whether it becomes a reality remains to be seen, but with Elon Musk at the helm, anything is possible. Even in the challenging year of 2022, Toyota achieved remarkable sales of nearly 10.5 million cars, persevering despite the obstacles posed by the COVID-19 pandemic and chip shortages. So, what is the secret behind Toyota's status as a trusted brand for countless individuals? It all boils down to one pivotal element: their consistent production of exceptionally high-quality vehicles. Toyota's cars consistently secure top rankings across various categories, whether sedans, SUVs, hybrids, or others. Toyota also provides a diverse array of models to cater to a wide range of preferences, ensuring that there's an option for everyone. Another reason why Toyota vehicles are trusted and popular is that they retain their value exceptionally well. Even if you purchase a used Toyota, you can expect a respectable resale value when selling it, which is a substantial advantage. Additionally, Toyota fully addresses your needs when it comes to replacement parts. Their extensive network of dealerships and service centers spans the globe, simplifying the process of locating genuine Toyota components. This saves you the trouble of hunting for parts for maintenance and repairs, enhancing the overall convenience of being a Toyota owner. Toyota's commitment to producing top-notch vehicles has fostered profound worldwide trust in the brand, with their diverse lineup, high resale values, and easily accessible spare parts. What's not to appreciate? However, there's more to Toyota's charm than just spare parts and mechanics. This is where the focus shifts to their engines, and their dedication becomes evident. They've poured substantial resources into engine research and development, and the outcomes are as clear as day. Toyota has engineered some of the finest engines that have left a lasting mark on the collective memory of automotive enthusiasts. Currently, Toyota is pursuing a multifaceted strategy to attain carbon neutrality, and the potential for success is promising. The company boasts a rich history of trailblazing hybrid and plug-in hybrid vehicles, most notably with the groundbreaking Prius introduced in 1997. These innovative vehicles played a pivotal role in laying the groundwork for the current surge in electric vehicles. Despite this impressive heritage, Toyota has exhibited a degree of caution in fully embracing the all-electric trend. The controversy surrounding Toyota's reluctance to completely transition to 100% electric vehicles is a topic for contemplation. Various regions, including Australia, California, Canada, and the European Union, have already sanctioned the prohibition of gas-powered cars by 2035. This has put substantial pressure on automakers to shift from gasoline to electric vehicles as the drive to curtail carbon emissions gains momentum. In contrast, Toyota has publicly expressed its reservations by not endorsing the COP26 agreement, which calls for a complete shift to electric vehicles by 2040. The company has deliberately taken a cautious approach, arguing that the rush toward fully electric vehicles has overlooked several crucial considerations. Akio Toyoda, the former CEO of Toyota, faced criticism for taking this less popular stance. Toyota's approach is notably reserved compared to several competitors who have eagerly embraced the transition from gasoline-powered vehicles in favor of electric alternatives. Jaguar, a British luxury automaker, publicly committed to going entirely electric by 2025, back in February 2022. Additionally, Cadillac and Volvo have announced their intentions to sell electric vehicles exclusively after 2030. Toyota, renowned for its legacy of pioneering cutting-edge technologies, has taken an unexpected and somewhat surprising direction. This move has garnered attention and curiosity within the industry. However, the rationale behind their unconventional decision is undeniably compelling. Toyota's reservations stem from a belief that a swift and total transition to all-electric vehicles may not be viable in the immediate future. Akio Toyoda has voiced skepticism regarding the electric vehicle EV frenzy, cautioning against an overzealous rush into EV adoption. He contends that an excessive increase in electric vehicles could pose potential risks. His argument hinges on the substantial cost associated with electric vehicles and the need for more infrastructure to support their widespread use, making such adoption appear impractical. It's essential to recognize that this viewpoint is somewhat concealed from the public because electric vehicles currently comprise only about 1% of the global automotive fleet. Nevertheless, as the number of electric vehicles continues to increase, the practicalities of the situation may become increasingly evident. The primary challenge looming when electric vehicles flood the market will be the increased demand for electricity to meet the power requirements of these vehicles. By 2030, the United States will need to expand its power output by 40%, equivalent to an estimated $100 billion investment in the existing electricity supply chain. Even in regions in Europe and Asia with advanced grids, the growing demand from electric vehicle users could strain the infrastructure. While voicing his reservations regarding electric cars, Akio Toyoda emphasizes the necessity of hydrogen-powered technology. Toyota anticipates that this innovative engine will disrupt the entire EV market. In addition to his concerns about the limited range of electric cars, Toyota also raised alarms regarding the environmental impact of battery production and disposal. He also pointed out the insufficiency of charging infrastructure in general. Toyota's arguments hold substantial merit. There is insufficient power capacity to sustain a mass transition to electric vehicles. Secondly, the world's primary source of electricity is fossil fuels, which means that a surge in electric vehicles won't necessarily reduce emissions, but rather shift their source. Akio Toyoda's critics may overlook his essential point. Carbon, not combustion engines, should be the primary focus in the battle against environmental challenges. Looking at the bigger picture, it becomes apparent that the adoption of electric vehicles needs to be more consistent globally. While certain markets, such as those in Europe and China, rapidly embrace EVs, the United States lags behind and some regions, such as Africa, lack meaningful EV infrastructure. This inequality underscores that the world is not yet prepared to fully commit to an all-electric vehicle agenda. Toyota believes that transitioning entirely to electric vehicles would leave a significant number of its customers without viable options. In 2021, Toyota sold over 10.5 million units in more than 200 nations, securing its status as the automaker with the largest global market presence. The company holds substantial market shares across the board, particularly in underdeveloped nations with inadequate charging infrastructure. By 2035, these regions will likely struggle to establish the necessary infrastructure to support electric vehicles. Electric vehicles come with a considerable price tag, although they are currently affordable due to government subsidies aimed at encouraging their adoption. The future of these incentives is uncertain, particularly once mass production takes off. Many potential buyers might hesitate to invest heavily in electric vehicles without these financial incentives. In response, Toyota has proposed a more practical approach, advocating for a balanced strategy that includes hybrid vehicles and all-electric options. The company is strongly committed to advancing hydrogen-powered vehicles as part of its strategic vision. They aim to make hydrogen-powered vehicles a zero-emission alternative to traditional gasoline and diesel cars. To achieve this, they are developing internal combustion engines, ICE, that run on hydrogen, which could pose significant competition to the electric vehicle market dominated by lithium-ion batteries. It's evident just from the name that lithium is a critical component in these batteries, and unfortunately, it is not naturally abundant. Toyota's concern is that a looming lithium shortage may arise as electric vehicles are produced in larger quantities. Their solution to this challenge involves shifting from producing larger batteries solely for electric vehicles to creating smaller ones for hybrid cars. This approach can help mitigate the lithium shortage by utilizing more batteries with lower lithium content. Furthermore, hybrid vehicles emit fewer emissions compared to traditional gasoline-powered cars. The future of transportation, where electric vehicles dominate the roads, is still uncertain. Toyota, however, anticipates that an all-electric vehicle future will strain the world's metal resources used in battery production. In addition to lithium, there will be increased demand for nickel and manganese, two other essential metals in battery manufacturing. This heightened demand may affect battery costs, potentially impacting car prices. Toyota also argues that over-reliance on government incentives, which may be subject to change, is risky since only a small portion of new car sales currently comprise all-electric vehicles. There remains room for alternative vehicle types to enter the market. The company has opted for a different path, advocating for the hydrogen combustion engine. Now, let's delve further into why Toyota officials believe this technology could eventually surpass electric vehicles. Introducing the Corolla Cross H2 concept by Toyota. This innovative concept features a cutting-edge hydrogen internal combustion engine, ICE, prototype vehicle. The 1.6L three-cylinder turbocharged engine, known from the GR Corolla and GR Yaris, has been adapted to run on hydrogen. It harnesses Toyota's expertise in hydrogen technology, developed through the Mirai fuel cell electric vehicle. The vehicle is equipped with robust armored fuel tanks, strengthened connecting rods, durable valves and valve seats, and fuel injectors, all optimized for gaseous hydrogen to ensure safe hydrogen storage. The Corolla Cross H2 concept offers seating for 5 passengers, and its features resemble a regular Corolla, in a thrilling development for automotive enthusiasts. Toyota and Yamaha Motor have united to develop a V8 engine powered by hydrogen. This 5.0L V8 engine, built upon the foundation of the Lexus RC Coupe's power plant, has undergone modifications to its cylinder heads and fuel injectors. Yamaha asserts that it will deliver an impressive 398 lb-ft of torque at 3,600 revolutions per minute and 455 horsepower at 6,800 revolutions per minute. These performance figures make it an enticing option, even though its power output is slightly less than a traditional gasoline-powered V8. One remarkable advantage of hydrogen is its ease of refueling. In contrast to liquid fuels, refilling a hydrogen-powered vehicle like the Toyota Yaris GR-H2 takes about a minute and a half, a notably faster process than refueling a conventional gasoline-powered car, such as the Toyota Camry. Diesel fuel has historically been preferred for vehicles that haul heavy loads. However, in regions where temperatures plummet to negative double digits, diesel fuel can freeze. In contrast, unleaded fuel can withstand temperatures as low as minus 100 degrees Fahrenheit before freezing. Lithium batteries can endure temperatures as low as minus 140 degrees Fahrenheit, though rare incidents can still occur. In contrast, Hydrogen exhibits remarkable resilience, capable of enduring bone-chilling temperatures as low as -435 degrees Fahrenheit. This quality positions hydrogen as the optimal choice for extreme cold climates and underscores its adaptability to diverse environmental conditions. There are legitimate worries about the scarcity of essential materials, including lithium and battery-grade nickel, required for lithium batteries. These concerns could impede the production of batteries for electric vehicles. Leveraging the full potential of hydrogen-powered engines may be a strategic measure to mitigate potential delays in the transition to electric vehicles. One of the main challenges with electric vehicles, particularly automobiles and trucks, is the absence of the thrilling sound that comes with traditional internal combustion engines. Nothing quite matches the exhilaration of pressing the gas pedal in a classic muscle car, like a 1970 Chevrolet Chevelle SS with a big block 454 or a 1969 Ford Mustang with a 428 Cobra jet. The sound of the carburetor opening and the fuel surging into the engine, the power coursing through your chest, and the adrenaline rush are unique experiences that electric vehicles cannot replicate. However, hydrogen-powered vehicles offer a similar visceral experience. Furthermore, nearly every corner of the country is home to small local repair businesses, providing accessibility and convenience for hydrogen-powered vehicles. However, with the growing popularity of electric vehicles among consumers, traditional repair options may no longer be available. While you might attempt DIY electric engine repairs by watching online tutorials, consulting a certified mechanic with expertise in the latest technology is strongly recommended. One remarkable aspect of hydrogen-powered engines is their purely mechanical nature, resembling traditional ones. This means the local repair shops you trust can still effectively handle maintenance and repairs. However, it's essential to acknowledge that hydrogen has disadvantages, including high combustibility, challenging requirements for handling and storage, and nitrous oxide production during combustion. Toyota's approach to achieving carbon neutrality is notably diverse, as it explores various technologies to reach its goal of zero emissions. This contrasts with many other automakers that are placing their primary focus on electric vehicles. Given the ongoing energy supply concerns linked to the Ukraine conflict, European nations are seeking ways to reduce energy consumption. Switzerland has even proposed restricting electric vehicle usage to emergencies like errands or grocery runs, and this policy might become law. The future of hydrogen-powered cars holds potential with cutting-edge technology and hydrogen fuel cell electric vehicles. Still, their path to success may face obstacles due to the dominance of electric vehicles. Hydrogen-powered cars offer several advantages over traditional electric vehicles, such as extended range and quicker charging or refueling times. However, many technological advancements are needed for hydrogen-powered vehicles to gain widespread adoption. Currently, hydrogen production is costly and relies heavily on fossil fuels, and there is a lack of infrastructure for hydrogen refueling stations. Additionally, the popularity of non-hydrogen electric vehicles like Tesla's may be a significant hurdle to the widespread acceptance of hydrogen fuel cell electric vehicles. People need a compelling reason to switch from their existing electric vehicles. Until such a reason is presented, hydrogen-powered cars might continue to struggle for recognition. The technology behind hydrogen fuel cells has existed for quite some time, originating in the late 1960s to provide power for NASA's manned space missions. Over the years, this technology has been refined and is now applicable for terrestrial vehicles as an alternative to traditional internal combustion engines. A conventional hydrogen fuel stack comprises an electrolyte membrane, an anode, and a cathode. Oxygen is supplied to the cathode, while hydrogen is provided to the anode, divided into protons and electrons. The protons pass through the membrane, converting into water, while the electrons are directed into a circuit, generating electricity. Hydrogen fuel cell electric vehicles utilize a robust tank of compressed hydrogen, which passes through the fuel stack. In contrast to conventional electric vehicles powered by battery packs, the vehicle's electric motors are driven by this converted electricity. In doing so, they emit only harmless water vapor from the exhaust. While one of the main criticisms of electric vehicles is their limited range, hydrogen-powered vehicles can address this issue. For instance, the Hyundai Nexo can cover 385 miles on a single fill-up. In comparison, the Toyota Mirai can travel an additional 400 miles, surpassing the typical electric vehicle range of around 250 miles. The duration required for electric vehicle charging is the second most common grievance among owners. Charging an electric vehicle's battery pack fully at home typically takes 8 to 40 hours. In contrast, refilling a hydrogen fuel cell electric vehicle is a matter of minutes, functioning much like the refueling process for gasoline-powered vehicles. Both Toyota and Hyundai offer complimentary fill-ups for their H2 vehicles. Toyota provides free hydrogen refueling for 6 years or up to $15,000, whichever comes first. Hyundai offers similar terms with 3 years of free refueling or a maximum of $13,000. Nonetheless, a pivotal challenge hindering the extensive adoption of hydrogen fuel cell vehicles centers on the need for more refueling infrastructure. There is a shortage of hydrogen refueling stations, with just about 60 in the United States, concentrated entirely in California, roughly 15 in Great Britain, and only a few in Canada. This scarcity of refueling options is a significant barrier to the widespread acceptance of hydrogen fuel cell electric vehicles. The cost of hydrogen poses another significant barrier. While automakers may initially provide complimentary refills, owners eventually bear the expense. Hydrogen prices are on par with gasoline, occasionally reaching an outrageous $12 per gallon. To foster the success of hydrogen-powered vehicles, the cost of hydrogen must be reduced to approximately $2 per gallon, aligning it with the cost equivalent to electric vehicles. Another drawback is the claim that hydrogen fuel cell electric vehicles are less environmentally friendly than portrayed. The production of hydrogen consumes substantial energy, primarily sourced from fossil fuels, accounting for 99% of the production. While the vehicle does not emit pollution, its fuel production's environmental impact is notable. To increase public interest in hydrogen vehicles, it is imperative to find renewable energy solutions for hydrogen production. The key lies in developing essential infrastructure and discovering more affordable, environmentally friendly methods for hydrogen production. Given that this technology is still developing, it's reasonable to expect ongoing advancements in its application to power vehicles. Hydrogen fuel cell electric vehicles have the potential to become robust contenders against electric vehicles by aligning their cost-effectiveness. However, even if hydrogen-powered vehicles were to reach a level of affordability and practicality similar to electric vehicles, battery technology is also progressing and extending range, potentially negating the advantages of hydrogen fuel cell electric vehicles. Electric vehicle owners may have little motivation to transition from a Model S to a Mirai when the performance is comparable. Ultimately, consumers tend to adhere to what they are accustomed to. Nevertheless, Toyota has garnered significant attention with its dynamic force engine strategy. This concept revolves around enhancing thermal efficiency. For example, Toyota has achieved motors with an impressive 41% thermal efficiency today, a remarkable accomplishment compared to the typical gasoline engines with efficiencies ranging from approximately 25% to 33%. Ultimately, the decision rests with the consumer. Both battery electric vehicles and high hydrogen combustion engine vehicles can significantly contribute to an eco-friendly transportation system. It's well recognized that these technologies are unlikely to replace one another. Instead, they will coexist and cater to various needs based on individual consumer preferences and circumstances.